The first op-amp circuit we're going to look at is very, very simple and not completely useless, but there are, if we wanted to do its job, there are better ways of doing it. But anyway, so this is called an open loop comparator. Comparator here means like something that compares to other things, and you'll see what I mean in a second. So let's say we have our op-amp, we have our V out at the output, we have at the non-inverting input, we have a sine wave going in. So we have something that looks like this. It doesn't really matter what this voltage is, but maybe this is like 1 volt or something like that. And the inverting input, we are just going to ground. So this is 0 volts. Okay, so I'm going to call this V in. This is the input to our comparator. The comparator is, the thing in the middle here. So if we draw a little graph of what the input looks like, it is just a 1 volt sine wave. Not super interesting. But our output is going to not look like this. So let's see what the output's doing. So let's start in part of our cycle where we are at plus 1 volt, just as an example. So when this is plus 1 volt, our positive input is plus 1 volt, right? So V plus is plus 1, V minus equals 0 because it always equals 0. So the difference between those inputs is going to be 1 minus 0. And I didn't bring a calculator, but I think that's 1. So our output is equal to 1 times the gain, which equals, I don't know if we have a gain of 1,000,000, this is 1,000,000 volts. Now, of course, we can't really have 1,000,000 volts. This op-amp has some limit to the voltage. If we're not told otherwise, we'll assume that's plus or minus, or between plus and minus 15 volts for this class. So instead of outputting 1,000,000 volts, it's going to get as close as it can, which is not very close. It is going to be at plus 15 volts. So in other words, I'm not going to draw this to scale, but our output is going to be up at 15 volts. Okay, now can we think of anything that is going to change this? Because if this is 0.5 volts, we're going to get 0.5 times 1,000,000, which is 500,000. So we're still going to be at 15. Basically, for every positive value, we are going to be at plus 15 volts until we get to something really close to 0 when it's going to go down to 0, right? So this is, the sine is V in, the square thing is V out. If our voltage is negative, if V plus is less than 0, right, for this part of the sine wave, then we don't have 1 minus 0, we have something like minus 1 minus 0, which is going to give us an output of minus 1, or sorry, a voltage difference of minus 1, so this gets a minus 1, so this is minus 1,000,000. So we're at our limit down here, we're at minus 15 for every negative voltage. And over here we're positive again, so here we get the same thing. So this comparator, we can think of what it's doing here in 2 different ways. It looks like it is turning this sine wave into a square wave, and that's definitely one way of expressing this. So it's taking this 1 volt sine wave, turning it into a 15 volt square wave. Another way we could think of this is if we think of this plus and minus 15 as 2 different outputs, like this output means, this output value means the input is positive, this value down here means that input is negative. So if we're interpreting the output voltage of this, if we're just measuring this output voltage over here, this tells us what's going on at the input, because here the input is positive if we're measuring plus 15 volts, if we're measuring minus 15 volts, the input is negative, and if we're measuring something else, something has probably gone wrong. So in that way, the output is comparing these two inputs and giving us the result of that comparison as a plus or minus 15 volt signal. So that's the essence of a comparator. This is kind of useful. If you were going to have a comparator, you probably wouldn't make it with an op-amp. You'd probably buy a comparator chip. They are used for certain things. But anyway, this is not taking advantage of the op-amp's powers properly. So the next circuit we're going to look at is a more respectful to the op-amp.